Very good morning to Miss Naslin and my fellow friends. So my name is Nur Maisarah Aida. Today our groups will present a virtual experiment which is wave interference. Interference is the phenomenon in which two waves superpose to form the resultant wave of the lower, higher or same amplitude. The most commonly seen interference is the light interference. This means that light waves coming out of a source do not have a constant amplitude and frequency of phase. So the objective of this experiment is to observe interference pattern with light, to demonstrate light behaves as a wave, to carry out calculation related to double slit interference. Next, we move on to the first objective.
Hello, my name is Alysheron, and I will explain the procedure for the first objective, which is to observe interference pattern with light. So firstly, click on the wave interference and click interference. Click on the top tab that says light. Click screen and intensity. Move the amplitude and separation sliders to see what happens. So for this part, for the first trial, we use 1000 separation. And set the amplitude to 0. So there are no observations for 0. We proceed to the middle amplitude. So the observation is recorded by screenshotting this screen. Okay, we proceed to the maximum amplitude. So the observation is recorded. Okay, next, all the step is repeated by changing the color and see what happened to the wavelength and frequency. So for this part, we use the minimum frequency and the amplitude is set to 0. So no observation. Next, we proceed to middle. Yes, so the observation is recorded by screenshotting this simulation. Yeah, next we proceed to the maximum amplitude. Yeah, so the observation is recorded. Okay, next we use the maximum frequency with amplitude 0. So there are no observation for 0 amplitude. Next we proceed to the middle amplitude. Yeah, so the observation is recorded. Next we proceed to the maximum amplitude. Okay, lastly, all the step is repeated by using 2000, 3000 and 4000 separations. So I think that's all for objective 1. We proceed to objective 2.
For objective 2, I will present for the slits, which is to determine how light behave as a wave. My name is Wan Ahmad Azeem Najhi bin Wan Azizi. So, first and foremost, we will using light as the wave spot in this experiment, and then turn on the screen and the intensity part, and then from one slit we choose two slit to determine how light can behave as a wave. And then we adjust the slit width and the slit separation for 400 slit width, and then for the slit separation to 1600, and then turn on the wave spot and observe how the light behave as a wave on the screen and the intensity graph. And then by using the ruler and the timer in the simulator, we can calculate the velocity from wavelength and the frequency. So first, we need to calculate the wavelength by determine one wavelength from one peak to one peak. So turn off the pause the wave spot, and then calculate one spot, one peak to one peak by using the ruler in the simulator. So from here, we can calculate the wavelength, which is approximately 526.5 nanometer. So for the timer, to calculate the time using the timer given in the simulator, and calculate the time given for one wavelength, which is from one peak to one peak. Turn on the timer and then turn on the wave spot and stop exactly when it reach one peak to one peak across the slits. So the time in seconds, which is approximately 1.9 fs, is equal to, we need to multiply by 10 to the power of negative 15 second to get the value in seconds. And then by using the formula frequency 1 over second, we can calculate the velocity for the wave by using the formula wavelength multiplied by the frequency. And then by moving apart to the next part, we adjust the green arrow below the wave by moving closer to the source and turn on the wave spot. Observe the difference occur in the screen and the intensity peak. Again, by moving the green arrow further from the wave spot. And observe the difference occur and record it in the result. Lastly, repeat all the steps in the objective 2 by adjusting the slit width from 200, 400 and 600, and then for the slit separation, adjust from 1600 nanometer to 2400, and lastly 3200 nanometer. That's all from objective 2. Thank you.
Okay, so my name is Hafizahwati. I will explain about the objective 3. So firstly, in this simulation, we will go to the slits part. So after that, we click on the tab that says light and change it from one slit to two slit. So, okay, then we set the slit distance to the screen at the middle, the frequency to the highest setting, set the slit width as small as possible, and the slit separation as large as possible. Okay, we turn on the simulation. So then we use the measuring tape in this simulation and measure the slit distance to the screen. and then we measure the distance between two bright screens. Okay, so after we gather all the data, finally we will record our result in the table of the objective tree. So we proceed to the conclusion.
So yeah, I'm Mohammad Ali Laksamana. Moving on to the last part, conclusion. To sum up, the objectives for the wave interference which are observing interference pattern with light, demonstrating light behaves as a wave and carrying out calculations related to double-slit interference were well achieved. Furthermore, the simulation allows us to change the variable to a value resulting on screen which we can observe the wave pattern. By using the wave interference simulation, it is easier for us to observe the behavior of the light as a wave on the changes of wavelength and the frequency, especially when the light was changed also with slits or no slits. So that is all from us. Thank you.